Okay, Assalamualaikum and a very good day to everybody. Okay, so this is the video on topic 5, limits and continuity. Okay, I hope everyone is doing well. Alright, so we proceed to this chapter, limits and continuity, but we will look through some objective of this lesson. Okay, so by the end of the lesson, students should be able to define limit, explain the concept of limit at any given point as a, where limit f(x), x approaching a equals to L is a constant value, L, state and explain the basic properties of limits, explain cases where limit f(x), x approaching a over limit g(x), approaching a is equals to 0 over 0. This is we call as indeterminate form. Find the limit using substitution, factorization, and multiplication of conjugates. Discuss one-sided limit. Explain the existence of limit. Define infinite limits and define limit at infinity. Okay, so what is limit? Alright, I believe that some of you have heard about limit and some of you haven't. Okay, but it's okay, we will look through what is limit and continuity all about. Okay, what is a limit? Okay, basically we are not interested in the value of f(x) when x equals to a. Usually you are given a function f(x) and whatever value of x that we substitute inside your f(x), we will get some value. Okay, but in this case we are not interested, let's say we substitute x equals to a. We are not interested in finding fa equals to what value. Okay, we are interested in the behavior of f(x) as x comes closer and closer to the value of a. It means that, okay, if you have a function f(x), we want to check what happened to your f(x) when your x is approaching this value a. Okay, and the notation is we write it as limit f(x), x approaching a equals to L. Okay, L is a constant value, right? So for example, limit x squared plus 1, and we want to find when x approaching 0. Okay, previously you are given function f(x) equals to x squared plus 1, and then find the value when x equals to 0. So we just find f(0) and 0 squared plus 1, and you got it 1. When x equals to 0, it is equals to 1. And then what happened to the function f(x) when your x is approaching that 0? Meaning to say, when your x is like 0.0001 or negative 0.001, where your x is approaching 0. Okay, so if you look at the table here, this is a random number. We want to show that it is approaching 0. So this is your x. Okay, so this is your x. We want to show here when your x is negative 1, you get 2. When x is negative 0.5, you get 1.25. So if you can see here, this value is decreasing to 1.2. When x equals to negative 0.25, it is decreasing again. When x is equals to negative 0.001, it is approaching 1.0001. Same goes when you are from the right side. when x equals to 1, you get 2. When x equals to 0.5, same thing, 1.25. This one also the same. And when you substitute x equals to 0.01, you get 1.00001. What if you substitute negative 0.00001 or positive 0.00001? It might decrease less than 1.00001, meaning to say it is approaching 1, right? It is approaching value of 1. Okay, so this is what I'm explaining just now. X is approaching from left and x is approaching from right. Okay, so more clearly, if we look at the graph here, same thing, fx equals to x squared plus 1. So where is your 0? Your 0 is here, kan? Okay, your 0 is here. So now we want to see what happened to your fx when your x is moving, approaching 0 from the right side. This is from the right side. And this one is moving to 0 from the negative side, from the left hand side. Okay, x is approaching 0 positive. That's the meaning. 0 positive is you are moving from the right side. 0 negative is from the left side. Okay, so moving to the right side. So what happened is your graph is going to 1, is going down, and it is approaching y equals to 1. And then same goes to when x is approaching 0 negative. Okay, from the left hand side, so your graph is going down. Okay, so we can say here when x is approaching 0 or x is approaching from negative and right side, your fx is approaching 1. Okay, so we can say like this. Okay, when x limit x squared plus 1 when x is approaching 0 negative equals to 0 positive and it is equals to 1 is one value. Okay, understand kan? Okay, when does a limit exist? Because limit can also be non-exist, tidak wujud. Boleh wujud ataupun tidak wujud. Okay, the diner example. If you look at here, alright. For example, you have two car, green and blue color. They are moving to the same destination. Okay, so for example, the green color, okay, he arrived at the, I think this is a shopping complex or a cafe, and then the blue car also going to the same destination. So we can say that the limit exists at the cafe. Okay, all right. Okay, like for example, this arrow moving to one point and then the other one moving to the same destination point. So there exists a limit here, the value. Okay, next example, if you are given fx equals to x square, same thing. If we are focusing on find limit, okay, limit x is approaching 0 negative. Okay, 0 is here. So 0 negative is here, 0 positive is here. Okay, fx. So they are the same from right hand side as well. Limit x approaching 0 positive fx. This is equals to 0. Okay, equals to 0. But let's say, okay, this is different values of x having different values of y, meaning that when x equals to 1, it is equals to negative 1. When x equals to 2, it is equals to 4. When x equals to 3, it is equals to 9. Negative 1 equals to 1. Negative 2 square is 4. Negative 3 square is 9. Okay, let's say we want to find the limit when x is approaching 2. So 2 positive is from right hand side. 2 negative is from left hand side. Okay, if you can see this arrow, okay, this is approaching approaching fx, approaching 2 positive. X is approaching 2 positive. But then this one is approaching to negative. Okay, and they meet at the same point when fx equals to 4. Okay, so we can say that limit x square when x approaching 2 negative. Okay, 2 negative is this direction, where this direction, sorry, not this direction, this is from the right hand side. 2 negative is from the left hand side, and 2 positive is from the right hand side, this here, and it is equals to 4 because they meet at the same destination. Okay, limit x, so we can say that x is approaching 2, x approaching 2 is equals to 4. Okay, next example, if you are given gx equals to x square minus 6x plus 8 over x minus 2. So x minus 2, in order for the gx to be defined, x cannot be 2, kan? X cannot be 2. So meaning that your graph um, will be having a hole in between where it cannot touch at 2. Okay, here. So here is 0, here is 1 and 2. So you have no value when x equals to 2 because when you substitute x2 here, so it will be divided by 0. So empty hole here. Okay, so graph is discontinuous at 2, negative 2. Okay, discontinuous. Alright, so if you can see here, this is substituting x equals to 2, so you have 0 over 0. Okay, you can't divide any number by 0, can? That will become undefined. Okay, but then a limit still exists at x equals to 2. Why? Because this is still moving to the same destination even though there's a hole there. Okay, because we can find when x is approaching 2 positive, 2 negative from the other side. All right, okay, you can see the blue arrow and the purple arrow, they are having the same destination at y equals to negative 2. Okay, still the limit is exists, but what if you have fx like this? Okay, this is your fx, and then you want to find the limit when approaching 4. Okay, approaching 4. So yellow arrow is showing you what happened to your graph when x is approaching 4 positive. This side, can, on the right side is approaching 4 positive, and then the value will be equals to y equals to 2. Okay, it stops here and you can find the value. Okay, meaning that we can write as x approaching 4 positive fx, you get it as 2, right? And then yellow arrow, okay, it is moving approaching 4 negative, 4 negative, okay, 4 negative, and it stops here when fx equals to 1 or y equals to 1. This is y, kan? Y equals to 1. So we can say that limit of fx, x approaching 4, does not exist. Why? Because limit, okay, x approaching 4 positive fx is not equal to limit x approaching 4 negative fx, since this is equals to 2 and this is equals to 1. Okay, so we say that limit x approaching 4 does not exist. Okay, you see here the yellow, the green car and the blue car, they didn't meet at one destination. Okay, so right hand limit equals to 2. Okay, left hand limit equals to 1. Okay, so since they are not equal, so meaning that the limit is not exist. So you have to remember this definition. Limit fx, x approaching a, only exists if and only if. If and only if, meaning that, okay, that is the symbol for if and only if. Limit fx, x approaching a positive equals to limit fx, x approaching a negative. What does it meaning by this is you have two statements. The first one, if if limit x approaching a fx exists, then limit x approaching a positive fx equals to limit x approaching a negative fx. Statement number 2, if the other way around, if limit x approaching a positive fx equals to limit x approaching a negative fx, then limit x approaching a fx exists. Okay, that's the thing, yeah. Okay, what if your fx just now kan, this arrow we move it down. Okay, we move it down. Now they meet each other kan. Okay, now we can say that gx exists at x approaching 4 because they meet at one equal destination, the same destination. Gx is continuous at x equals to 4. Just now, this is the previous example. Because they didn't meet each other, so we can say that limit fx does not exist. Okay. Limit fx exists x approaching 2 even though fx is discontinuous at x equals to 2. Okay. This is the same example like the fraction 1, gx equals to x squared minus 6x plus 8 over x minus 2. Because x cannot be equals to 2. So you have empty hole there where your graph, this is fx. Your fx discontinuous at x equals to 2 still exists. Why? Because limit from 2 positive equals to 2 negative. Same. Okay, how do you evaluate a limit? Okay, I will explain you this subtopic in the next video. Okay, I'll see you soon. Thank you.